Hello, good morning, and welcome to this second episode of a series of webinars related to climate service produced under the European Clara project by CMCC and the project partners. A brief introduction to the Euro-Mediterranean Center on Climate Change, a non-profit research organization established in 2005. CMCC research is focused on climate change and its interaction with the environment, the society, business and policymakers in order to stimulate sustainable growth, protect the environment, and develop both mitigation and adaptation strategies. The center has offices in Lecce, Bologna, Capua, Milano, Sassari, Venezia, and Viterbo, involving public and private entities working together on multidisciplinary studies. CMCC scientific activities are distributed among 9 research divisions which share different knowledge and skills in the wide field of climate science and cover a variety of topics, including climate simulations, hydrogeology, impact modeling, climate services, economics, mitigation and adaptation policy, agriculture and forestry, and ecosystem services. The outreach of these activities come in the form of scientific publications on international journals, events and communication activities for the public at large, and targeted educational programs. The next forthcoming webinar will be about 2 different topics. One is about the target of the climate target of 1.5 degree by Sara Lovisolo, and the next one will be about another climate service, so the water irrigation for Irclim. Now I will pass the ball to Cristiana that will introduce the today's webinar.
Thank you, Madia. Hello, everyone. My name is Cristiana Fotiadou. I'm from the Swedish Meteorological and Hydrological Institute, and I will be the facilitator for today's webinar. This is the Clara Project webinar series. We have 6 webinars. We started last week with the first one on flood risk management. Today we are 3 services on the water management sector, and in November we have 2 webinars, one on the services concerning agriculture and another one on 4 services concerning the energy sector. And in December we will have a webinar on the air quality services, and we will close this series of the Clara webinars on 10th of December with the 2 services that are dealing with climate data and tools for impact analysis. A short introduction on what is Clara. Clara stands for Climate Forecast Enabled Knowledge Services, and the main objective here is to develop a set of climate services that build upon the Copernicus Climate Change Service, seasonal forecast, and the sectorial information systems, and mainly to demonstrate their value and ensure their market value. Clara is a Horizon 2020 Innovation Action Project, and we are currently in the last year of the project. We have developed 14 climate services, and we are in total 10 partners from academy, business, and public administration. Today, our theme is can seasonal forecast and climate change projections effectively improve water planning? And we have 2 presentations. The first presentation is on 2 services. The first one is on AQUA, on water supply assessment tool developed by SMHI. And the second one is on reservoir operation assessment tool, otherwise known as ROA, developed by the University of Cordova. Both of them will be presented by Carolina Candone. Carolina is a consultant hydrologist here at SMHI. And the second presentation is on the PWA service, Parma River Basin Water Resource Assessment, developed by ARPAE, and will be presented by Cinzia Alessandrini, a technical employee of the Regional Agency for the Environment and Energy from ARPAE, Italy. After the 2 presentations, we will have a Q&A session, so please write down your questions and I will gather them and address the question to each service that it corresponds to. A reminder that this webinar is recorded and will be uploaded on the CMCC YouTube channel and the Clara website and Facebook account. If you have any further question about the webinar, please contact CMCC in the email that you see here. I will now, without further ado, I give the floor to Carolina.
Hello, good morning. Thank you, Cristiano, for the introduction. Today I will describe the two services, AQUA, the water supply assessment tool developed from SMHI, and ROAT, the reservoir operation assessment tool developed from UCO, University of Cordoba. The presentation has been done from me and Javier Herrero from UCO, who is a senior researcher at the University of Cordoba and has been in charge for the design and development of ROAT. And he's also here, so during the Q&A sessions, if there are any questions related to ROAT, he will be able to answer them directly. Okay, sorry. Yes, so as said, our services, our climate services are addressed to the water management sector. So this sector is strongly affected by weather seasonal variability and changes in precipitation and temperature patterns as they affect the availability of water resources. So in this slide, we have gathered some article news from Sweden and Spain that were highlighting the water situation and the effects on society. So, for example, in Sweden, we had in the last recent summers very hot temperatures and lack of precipitation that led to water scarcity for the whole country, but especially in the southwestern region of Sweden. And this had very negative consequences as water shortage for urban water supply and irrigation, risk for wildfires, and effects on farmers who didn't have feed for their animals. On the other hand, in Spain, the water shortage is a well-known issue that is also causing a sort of competition for the access and the use of water for different aims, such as human consumption, irrigation, energy, and environmental flow. And in addition to that, there are more frequent and more severe flash floods that also have tremendous consequences on people and society. So it is really important for water manager to cope with these changes in way to ensure the access for water and also reduce the risk. So how climate services can help the water management sector? So basically, climate services can help increasing the awareness both of the current situation but also the future water situation by providing tools that can describe the seasonal variability. So we have developed online and user-friendly systems that show both real-time observation and modeled results as well as forecast, aiming at assisting optimal planning of water resources, also by giving an idea of how different strategies in water management can affect results in the long term. In this way, we can really support the decision making in this sector. So here, Javier and I have listed similarities that our two services have, AQUA and ROAT. So as I said, they are both addressed to the water management, and they are a web-based application that are designed to have a basic and an advanced version. And something that was really important is that they have been through the co-generation process. So we have designed and developed these services in close contact with the end users. More on the technical side, both the services are adaptable for reservoirs, while Aqua also describes natural water bodies and groundwater aquifers. Both the services show real-time measurements and real-time hydrological modeling, together with short-term and seasonal forecasts, and also the possibility to compare this current situation with the historical conditions, and also to have an idea of different seasonal management options to help understand how different strategies will affect freshwater availability. While the ROAT service has also two very unique features, which are the multiple simultaneous demands, which is one of the main aspects of the problem that they want to solve, and optimization processes that allow to really optimize the use of water for different needs. And also from the Aqua services, it's possible to export the results that are visualized. So I will start first with the Aqua, so the SMHI, the water supply assessment tool. This service was developed together with Region Gotland, that's been our users, because Region Gotland had experienced very hot and dry summers, and they had to cope with this water shortage. So they needed tools to really be able to plan in good time in case of extreme or uncommon situation. So the main aims of these services are to evaluate how different water extraction strategies affect the freshwater availability on the long term. So to improve the drinking water production, while at the same time ensuring the compliance on the existing water regulation, and so to support the decision-making process through the provision of graphs and that show in a very clear and intuitive way the results, and on the long run also to reduce the risk of damages to the infrastructures. So this is the workflow and system structure for Aqua. As I mentioned, this was developed in co-development with Region Gotland. And going from left to right, basically we have local data that are provided from the user that are collected in an FTP account. And this data is about groundwater or surface water levels together with water withdrawal rate. And this information is saved in our database. But together with these measurements, the user is also able to provide us with different alternatives, here noted as Q-pump alternatives, which basically are the different strategies covering the whole year. So this will also be used to evaluate the results. So in addition to that, we have the short-term forecast that covers the 10 days ahead, plus hydrometeorological variables, parameters that are modeled with the HYPE, that is the SMHI hydrological model. And so all these inputs are feeding the hydrological model that simulates the water balance in the reservoir. And from this, we get an HCDF file that then is read in the platform, in the web-based platform that you can see here on the right. So basically, you see a basic map, and clicking on the point, you see the graphs from the water levels, also in forecast, and in forms both of graph and as a table that is exportable. So going a bit more into the detail of the demonstrator, these are some screenshots from the station observation menu. So basically it is possible to choose what parameters is available, and this appears as points on the map, where there is both the name of the station and the latest measured value. When you click on a point, the graph appears with the past 30 days measurements and the 10 days forecast from it. Another aspect of the demonstrator is the availability of national scale modeling. So basically we have, in this case, we have used HYPE calibrated on the Swedish area, and we have produced these layers for different parameters such as precipitation, temperature, snow, groundwater recharge, or water runoff. And by clicking on every point, you see the HYPE subbasin, and also, as before, the results appear in form of graphs and tables. These models run daily, so you can also see when the latest model has run. So from national scale, we also do local scale modeling. That is what we have done for describing the freshwater availability in lakes and for the groundwater. So this is an example of visualization of the seasonal forecast. So basically, this is you see the visualization for 1 year. Where the black line represents the measurement for the past 6 months until today. And then there are the seasonal forecasts for the 6 months ahead. So as you see, there are 2 lines, the green and the blue, and they basically are linked to which kind of water withdrawal strategy you are considering. So, for example, the blue line represents the water levels that would be if the latest extraction value is used constantly for the next 6 months, while the green one shows the water level for a sort of normal strategy. And also the background colors represents the historical normal values and define what are the different levels, like that are high below, near normal, or above normal. So to have very easy to understand comparison with the current situation and the historical situation. And plus we also get the critical water levels that are here displayed as the dashed line. Another aspect is that Aqua is customized according to the user needs. So we have a basic and a plus version. So basically both. So the Aqua Basic allows you to have an open access or a private access with username and password, and it's basically aimed to visualize the observations from the station. So the visualization of the real-time hydrometeorological station, and visualize these results and archive data in graphs and tables. While the Aqua Plus has all the features that also the basic has, but also the local scale modeling of the surface and groundwater reservoirs, short range and seasonal forecast, daily update of the results, and the inclusion of water withdrawal and critical water levels from the users. And also both the versions are supported by desktop and mobile devices, and they are language independent. So now I will talk about the ROAD service. So the ROAD service, the Reservoir Operation Assessment Tool, is a climate service that aims to be a tool for managers of reservoirs so that they can take advantage of knowledge of the European meteorological weather forecasting field. So this service has been designed for multi-objective reservoir in the Mediterranean areas, these regions are characterized from very limiting water resource. So these reservoirs are intended to serve water to different purposes and different users who figuratively have to compete for it. So basically the same water resource has to be used for irrigation, hydropower production, drinking water, and environmental flows. But on the other hand, these watersheds are periodically affected by annual droughts and recurrent flash flood events. So the management of this sort of reservoir is very complicated because it's highly dependent on climatology and because of the general lack of water, and also because they are subjected to different operational rules and exploitation criteria. So this is the workflow for the ROT. The ROT, as Aqua, both the services have been developed with an intense dialogue between the service developers and the final users of the services, which in this case are the managers of the Besnar Rules Reservoirs Exploitation System. So, and this was actually the base for all the climate services within the Clara project. So ROT is accessible through a web-based application where both maps, graphs, and tables are kept very simple and intuitive, also for non-expert kind of users. So going through the workshop, the workflow, there is a topology panel that is a tool where the information of the system is accessed, grouped in graphical objects. So these objects are basically watershed, rivers, or reservoirs that are interconnected according to the user specifications. So the service will gather all the significant real-time data and will provide also the result of the hydrological model together with a forecast view for both short-term forecast and seasonal forecast for basin and river. And for the reservoir, it will also show the results depending on different management scenarios. So going a bit into the details of the application, this is screenshot from the real-time section that shows real measurements of river flow, groundwater level, precipitation, or temperature at each element of the system. So it shows also the result of the real-time simulations that are made with the hydrological model, WIMED, which is a distributed and physically based model, which allows to generate some information as snow cover and groundwater reserves. And these data that are simulated can also be compared with the historical record from any previous years. In addition to the real-time data, there are also forecasts. So there are this short-term section that shows the results for the 7 days forecast, and also the seasonal forecast. So this is an example from the seasonal forecast of the water reserves. So the seasonal section shows the hydrological forecast for the next 6 months that are calculated by the ECMWF plus the EHYPE model. And this hydrometeorological forecast is then transformed into reservoir state forecast through an internal reservoir balance model with different scenario on the management criteria. So because the weather forecasts have a probabilistic nature, which is not always easy to understand, this information is visualized in an intuitive way. So the user basically can explore the effects of different decisions over the management of the water for the next months, as the results will change according to which management strategy is selected, and these management strategies are anyway provided from the user. We also can define what are the thresholds that you see here in the graph on the background, describing what is normal condition or what is an emergency kind of condition. So, so this is basically all from us. Thank you for your attention, and I will pass it to Cinzia, I guess. So thank you.
Thank you, Carolina. Yes, before we pass to Cinzia, let me remind you that we have a Q&A session at the end of the presentation, also from Cinzia. So if you have any questions, please write them down in the question menu, and we will address them at the end. Thank you. Cinzia, the floor is yours.
Thank you, Cristiana. Just a moment. Let I open my presentation. Okay. Okay. So, thank you, Cristiana, and good afternoon to everybody. I will start briefly introducing the place where we work, and so where we developed the PWA service. In particular is ARPAE Emilia-Romagna, the hydrometeoroclimate structure, the hydrology service located in Parma. In particular, there is a big working group that I'm proud to show in this slide, because of course I wasn't alone in developing the PWA service. But why PWA? Why this name? The P, of course, was because Parma is the place where we live, and Parma is the river that is a tributary of the Po River, and so we are near this river, and this was very, very easy to study because we have data. It's simple to access the data and the river, and of course there are strong pressures of pollutants and so on, and in particular it's important to define a methodology, and so we tried to begin with a small basin in order to define this methodology to extend to other tributaries of the Po River and to the whole Po River basin. The W is for water resources, of course is our main task where we work, and the A is for assessment, with regard to an overall assessment of the basin, considering so different aspects of the whole management of the basin. So, in particular, the PWA includes 4 different services: the water quality, the habitat service evaluation, the bed load transport, and the water resources management. Only the bed load transport is evaluated in flood events, during flood events. The other 3 services are evaluated during water scarcity events. Coming to the first service, the water resources management service, it was developed coupling the hydrological and the water balance model, in particular the Topkapi model with Ribasim model. And the modeling framework in which they were included is the drugged early warning system that is operative at the premises of ARPAE. Input data for this water management service are the hydrometeorological data, for example, rain, temperature, and level gauges, the seasonal forecast, 3 months forecasts, and the climate change scenarios, in particular the RCP 4.5 supplied by the CMCC. The output data of this service, for example, these are some examples, of course, of output data. And the first one that you can see up is the real-time forecast plus 10 days in Parma River Basin. So you can see that in next 10 days, high discharge, of course not so high, but there is a little peak. Another result can be the mean water availability for irrigation, considering a period. In order to have the second result, of course, we used the climate change scenarios. So we can compare, sorry for some some Italian words, we can compare the historical data with the scenario mode at 2050 and 2100. If we consider the blue line, that is for Parma Land Reclamation Board, we can see that based on the historical line, the future availability it seems to decrease based on our simulation. The second service is based on the weighted usable area, and is created to evaluate the presence or absence of the habitat in 3 particular species: the Barbus plebeius, the Leuciscus cephalus, and Salmo trutta. In particular, for, of course, in Parma River and for the adult life stage. We used the simulated stream flow series for the historical period and the simulated stream flow series for the period 2017 and 2100, other than the weighted usable area Q curves. These curves are curves elaborated using software, an habitat software that its name is FabSim, and it derives from a study led by ARPAE and the Emilia-Romagna region. The WUA curves show the habitat suitability for these target species, considering discharge variation. Our hypothesis in this service was that it's possible to find out a suitable habitat from an hydraulic point of view when the curve is greater than 50%, when the percentage, of course, of habitat is greater than 50%. So these are some results leading this study. For each species, we can show that we can find that there is a general decrease in the percentage in habitat suitability for each species. In our to-do list, there is the application of MesoHabSim method. That is an experimental method that we aim to test in a little branch of Parma River. And considering that this method takes into account the spatial and temporal availability in order to obtain the Habitat Integrity Index. The third service is on water quality. The water quality has the aim of analyzing the nutrient concentration evolution in the Parma River basin using numerical models. Of course, what we need, a database of chemical, physical, and morphological and hydrological parameters, and an analysis of diffuse and point sources in the basin. The main parameters, the 2 parameters considered are nitrogen and phosphorus, and of course they are fundamental for life. But if they are in a high values, high concentration, they can lead to eutrophication. In order to consider nitrogen and phosphorus, we had to evaluate the potential input explained with NANI and NAPI values. NANI and NAPI values consider the nitrogen and phosphorus also in atmospheric deposition, for example, nitrogen fixation, non-food phosphorus, for example, or net feed import-export, and so on. Okay, these are the results of our service of water quality. As you can see in the figures, there is the Parma River basin, and as you can see, we found, of course, an increase of human influence moving from the highest part of the basin to the lowest one, in terms, of course, of percentage. How we reached these results? We used the numerical model DELVAC, that is a model, a component of RIBASIM model, and we used the same schematization of water basin management, but adding some nodes typical of water quality, so considering nitrogen and phosphorus loads. These are some results of our water quality. This is the calibration, and as you can see, the simulated load in red fit quite well the blue dots that are the observed load. Coming to the fourth service, that is the bed load transport, it has the aim to develop a transport monitoring method in gravelly water bodies. As shown in the picture, the virtual velocity method uses tracers, colored gravel that are tracers because they have also passive transponders, and so during flood events we can search these gravels, these stones, and try to understand which kind of movement and how far they moved during the flood. The virtual velocity method, it's an application that we used, but it's site specific, of course, and in that place it permits of allowed to define the quantity of moving material and allowed to define the solid flow rate related to the discharge. This is an application, an example of application for solid transport. For example, we used the Jupyter Notebook, that is an open source web application that permits the users to create and share code, equations, image and text. And in this case, with some lines of code, a typical user can elaborate data supplied by PWA service for a particular site, period, and variables in which they are interested. So all PWA services are definitely linked together in order to provide an indication of the environmental status of the water body through an habitat index. But how can we supply this data that we produced with these services we developed? Results and data of the four services will be shared throughout an interactive system compliant to the WMO and OGC requests, including semantic and ontology facilities throughout the web services, for example, WMS, WFS, and so on. The service will support administration and authorities involved in water management and planning activities. The functionalities of our web platform is, of course, analyze the real-time condition of the Parma River Basin about hydrological status, water quality, bed load transport and presence or absence of habitat. Moreover, the access on seasonal forecasts of precipitation and discharge for the next 3 months. Another thing is select and analyze the water balance, water quality, bed load transport and habitat scenarios for next season. And the last but not least, select and analyze the water balance, water quality, bed load transport and habitat scenarios for the next simulated 80 years using the RCP 4.5 scenarios. These are images of the web platform. On your left, you can see green dots that are a summarization of more sites. So if you zoom, you can explode them. And in the second one, you can see an example of the water management service. Okay. The principle based on our platform is with the broker web services. So we need a broker, we have a broker that can mediate and translate the data format from data providers to the users. So the user can decide how they want to view their data, for example, using web client, the WaterML web client, or the SOS web client, or again the WaterML but the desktop client. So every client is supported because we provide data with a standard format. So thank you for your attention.
Thank you, Cinzia, for this excellent presentation. I will ask all the presenters to come to the screen. So we have everybody. We are right on time, so we have approximately 20 minutes for a Q&A session. And I invite the audience to place their questions. Unfortunately, I cannot give you the microphone because I see some hands rising from the attendees. You need to write the question on the question menu so I can read it. But I can start with a question for Cinzia. You've mentioned that the users can go into the code and provide their own data. How easy is this for a user? Do they need specific training, or do you address specific audience, basically? You need to unmute, yes.
Sorry, I had switch off. Really, we thought to a big quantity of users, but of course the example I show, in my opinion, it's not for all users, because you need to know some lines of codes, you need to manage with with codes independently. But otherwise, using the platform, so they are different uses. Because using the platform, it's more easier for every user because it's not closed, the platform. So it's more easier because you can click and download your data or choose whatever you want to see. So if you want to visualize the discharge for a period, for example, in the present or in the future, you can choose the data you need, the variable, the place, of course. And so maybe with the platform, it's better because you don't need the training, specific trainings.
Excellent, thank you. I will continue with my questions. We are waiting questions from the audience. My second question goes to Carolina for the Aqua service. How well is the interaction with the users of the reservoir, of the lake, let's say, for the drinking water? Do you have examples of actually using the service and making decisions according to the forecast?
Well, as I said, we have developed the service with the Region Gotland, we were working with already for several years, and we have actually we had their feedback after the summer that they used our service in parallel to their usual, let's say, decision routine. But they gave us feedback that our forecasts were really good and they were in line to what they saw. And this, of course, built and strengthened the trust to use the service from next year to actually base the decisions upon it. So far we had a good experience from it. Yes.
Perfect. I have another question, Wendy, to both of you. How scalable is your services? Because you address very specific locations, but are they scalable in other areas? And it links with from the audience, from Vittorio Margletto. If it is applicable to larger areas, if you are willing to give training to Italian users for the services. Who wants to answer first?
I can start if Carolina agrees. As I mentioned in the first or second slide, I don't remember, our test area was the Parma River, only because we are near Parma River, and we have data and so on. But of course, our idea was, okay, let's start with this river, but then when we have a methodology, we know what we can do, we can extend to other tributaries, for example, rivers near the Parma River basin or the main River Po. So we hope to extend it. It's our intention.
Yes, perfect. Carolina?
Yes. So also for us, this service and the models can be scalable and can be used for other regions. And so far, we have worked mainly in Sweden, where we have a very strong relationship with users from different sectors, from the public and also the private sector. But it's in our aim within the Clara project and with the development of Aqua to actually try to get more in contact with different users, and especially also in Italy, where for sure these kind of monitoring tools would be useful to really understand what's the current situation and what can be the future situation. And I also say yes, we would be really happy to give training to this, because that's what we do already. When we build up the service for a user, then we always have like a meeting where, so they know the service from the beginning, but then at the end we also provide training for every single step, so they can easily use the service in their daily work.
Thank you. I have a question for Javier for the ROADs, but it's also applicable for PWA, since you're both using seasonal forecast for Southern Europe, for the Mediterranean area. And I would like to hear your opinion, how reliable is the seasonal forecast in that area from your experience? And especially making this type of services that the managers of the reservoirs need to make decisions based on the forecast. Maybe Javier, would you like to answer first?
Thank you, Christiana. Well, we have just started working with the seasonal forecast. By now we have found that we have a very small improvement with respect with, for example, other indexes like the mean values for every month. The seasonal forecast is showing a little bit of a skill, but it's not very high because we are talking about 6 months ahead. The climatology in this region is very difficult to model at those scales, but we think that this could be improved in the future. Right now we have a limited skill, it's true, but I think it's especially true for our regions in the south of Spain that has a lot of difficulties in being modeled by these regional models for climatology.
Thank you, Javier. Cinzia?
Okay. And for PWA, I can say that as we are the regional agency for prevention of the environment, we have a particular skill in modeling, hydrological and hydraulic modeling, in support also of civil protection. So we have a system that is operative, okay, and we already included this 3 months seasonal forecast, for example, for water management service, and not only for Parma River Basin, but for the whole Po River Basin. And so, what can I say? Of course, I agree with Javier that in our zone, in our area, of course, we need to improve, we need more research, but we already use them. And so, for example, we are in support of the Po River Basin District Authority during their meetings, monthly meetings, for example, during water scarcity crisis or water scarcity events. They meet each other with all the people involved in that emergency. So, for example, lake managers, hydropower, irrigation, and so land reclamation board, and so on. And the Po River Basin District Authority needs to manage and to advise how to distribute the water. Okay, and we support them with some bulletin or some graphs showing how the situation will be in the near future.
So you will say that the current situation, it's more of a supporting position the service takes in the actual decision making of the decision makers.
Yes, not only for planning, but also for emergency events. Yes.
Mm-hmm. Yes. Thank you, Cinzia. I have a question for Carolina and Aqua. You focus a lot on the groundwater forecast, because I imagine that it's specific to the lake, how and also the managers they see more the groundwater level forecast. But could it be other variables, or could the service address other variables if needed? Or is it specific to?
Well, the service could address other variables. At the beginning of the Clara project, there was a lot of discussion about what was the good parameter to show to really give an idea of the freshwater availability. So we actually discussed it a lot with the Region Gotland about what was the more explanatory, let's say, the best variable to simulate, and of course this has changed during the time, also according to which kind of data we had and what were the local conditions. So that's why in the end we agreed to simulate the inflow to the open lake and the groundwater level. But I mean, in principle, there would be other variables that could be interesting for them, as the effective precipitation. That is, especially for the open lake, it's an important variable because it also considers the effect of evaporation. But so yeah, we have discussed other parameters to consider, but also we were trying to keep Aqua quite easy. So we are trying to avoid to put too many layers and too many submenus and so on, but try to really find what's the most important thing that can give the message and makes it easy and intuitive to use, to try to make it, to avoid to have it too difficult. Yeah.
Thank you, Carolina. I will remind the audience to pose questions if they have any. My next question is to Javier. You seem to have the most complicated, well, also PWA's complicated reservoir with, in respect to who takes the decision within the reservoir, and because you have a lot of water allocation between different sectors, let's say. What, on your experience, how do you treat the different opinions between the managers?
Okay, by the moment, is that the service is thought to be useful for the manager of the reservoir. He is in charge of all how the water is divided between the users. We are thinking, of course, this is a very limited market if we only go for managers of reservoirs, but we think that this tool could be also useful for the users of this water. I mean that maybe irrigators or hydropower companies Our idea is that they can have access to this service just to manage how they want to place or locate their demands along the year. By now, this is and then they have to talk to the managers of the reservoirs to establish a dialogue and to select what is better for each one. All these things has here, as water is so limited, has to be done this way. There's some preferences, of course, as for drinking water and for environmental flow, but then the preferences have to be established from dialogue. That's important. The more information that we can serve to them through this service, for example, would be just a good tool, a good input for the decisions that are made.
Thank you, Javier. So, if you have do you have any other comments that you would like to add in this discussion? Otherwise, we can close the webinar here. From the audience, if you have more questions, you can post them online. I don't see any questions at the moment, so if you do have any questions, you're free to write, and we will communicate to the presenters. Do you have any other comments yourselves, the presenters?
Okay, I want to thank Carolina for presenting on our behalf the service. That was not easy, but thank you, Carolina.
Thank you all for your great presentations and your time for this webinar. And to the audience, hope to see you soon in the next webinar of the Clara project. Thank you all. Have a good day.
Bye.
Bye.